Hello all, welcome to my YouTube channel. Today's topic of discussion is free body diagram. This free body diagram is very important as far as your engineering mechanics is concerned. So we'll learn about the free body diagram. But before going to the free body diagram, we should know the Newton's third law. It states that to every action there is an equal and opposite reaction. Hence, reaction is always equal and opposite to the action. Let us consider one example. This is a plane surface and a ball is resting on this plane surface. This is a ball and this ball is resting on the plane surface. This ball is free to move along the plane, but it cannot move vertically downward. Due to the surface, it cannot move vertically downward. Hence, the ball will exert a force vertically downwards along its center. This is the force that it will exert vertically downwards, and this force is called as the weight W of the ball. This weight W will always act under the action of gravity. Now this force is known as action. This force, it is called as the action. Now this plane surface will exert an equal force vertically upwards on the ball at the point of contact. Suppose this is the point of contact. Let us call this as the point of contact A. So here there will be an equal and opposite reaction at this point A. This is known as the normal reaction. Let us call it as R. So W is the action and R is the reaction. This is what the third law of Newton's says. To every action there is an equal and opposite reaction. Now the force exerted by the support on the ball is known as the reaction. Okay. Hence any force on a support causes an equal and opposite force from the support, so that action and reaction are two equal and opposite forces. Now if we need to find out the free body diagram. Okay, if we need to find out the free body diagram is also denoted by FBD. Normally it is denoted by FBD. Now consider in the case of this ball, it is, if you need to make the free body diagram of this ball, then the ball has to be completely isolated from its support. The support is this is the support. So in case of a free body diagram, the ball has to be completely isolated from its support and only the forces acting on the ball are shown. The support is removed and only the forces acting on the ball are shown. So the FBD of this ball will be given as, this is the ball, and FBD will be the weight acting vertically downwards and the normal reaction acting vertically upwards. Okay, this is the FBD of the ball, and the line of action of the weight W and this normal reaction R will be same only. Only thing is that weight will act downwards and reaction will act upwards. Okay. So FBD is the one in which the ball is completely isolated from its support and in which all the forces and reactions, they are acting on the ball. So hence, to draw the FBD of a body, all the supports are removed. See, the support was there, it has been removed and replaced by the reactions which these supports exert on the body. After removing the support, whatever reactions are there, that will be exerted on the body. Also, the body should be completely isolated. When supports are removed, so obviously the body will be completely isolated. Now let us consider this example of a ball hanging against a wall with the help of this string. So we need to draw the FBD of this figure, of this ball. So as we know that hence to draw FBD of a body, all the supports are removed. So here the support is this wall, and also there is this string that is supporting the ball. So these two are the supports. So these two supports has to be removed, and they have to be replaced by the reactions which these supports exert on the body. So this ball, it is supported by this string, and it is resting against this vertical wall at this point A. It is having a point of contact at A only. To draw the free body diagram of the ball, we have to isolate the ball completely. Okay, so we will first isolate the ball completely. That is, we have to isolate the ball from the support and the string. Okay, this is the wall, that is the support, and the string. We have to isolate the ball from the support as well as the string. And so let us first isolate it. So I have drawn this ball separately. Now first reaction on the ball that will act after isolating it will be the weight of the ball. So as we know, the weight of the ball will always pass through the center, and that too in a vertically downward direction. So let us say that this is the weight of the ball. It will always pass through the center of the ball. Second reaction will be the reaction of this string. Now we know that in a string there will be tension, and tension will move always outwards. This tension, it will always move outwards. So suppose this is the tension force, that too should also pass through the center of the ball, as the string is attached at its center. This O is the center of the ball. So let us say that this is the tension force T, and also as this ball is supported at this point A, so here there will be a normal reaction also, and this normal reaction should also pass through the center of the ball. This is the normal reaction at this point A. Okay. So these are the three forces that will act on the ball. First, what we did, we completely isolated the ball. Then we replaced the support by these reactions. Okay, we replace this string by this tension force, we replace this wall by this normal reaction, and also the weight of the ball would also act on it. So this is the FBD of the ball. Clear? Let us take another example. Draw the free body diagram of a ball of weight W supported by a string AB and resting against a smooth vertical wall at C, and also resting against a smooth horizontal floor at D as shown in figure. So here this ball is resting, and it is supported by a string AB, and this is resting against a smooth vertical wall at this point C, and also resting against a smooth horizontal floor at this point D, and it has a weight W. So obviously the weight will pass vertically downwards through the center of the ball. Now to draw the FBD of the ball should be completely isolated from the vertical support, that is this wall, from the horizontal support, that is this floor, and the string AB. Okay, so we will first completely isolate the ball. So this ball has been made separate. So after isolating it, we will show the reactions or the forces that will act on the ball. Suppose this is the center. So first force that will act will be the weight W acting vertically downwards. The next force that will act is due to this string. Now the string will carry tension, and tension will always go away. So let us say that this is the tension T. Also, the wall is resting at this point C. It is supported at this point C. So at the point C, there will be a normal reaction. Suppose this is the point C. So here one reaction will be there. Let us call this as reaction at the point C. So let this be RC. Also, the ball is resting on this floor at this point D. So this at the point D also there will be a normal reaction which will be exerted on the ball. Okay. So these are the 4 reactions or the 4 forces that will act on the ball. The first force is the weight W of the ball. This is given in the vertically downward direction. The second force is the tension force T in the string. Second force is the tension force T in the string. The third force is the normal reaction. This normal reaction RC. It is at this point C. It is at this point C. And the third and the fourth will be the normal reaction. This one normal reaction RD at this point D. RD will be at this point D. Okay, so these are the 4 forces that will act on the ball when it has been completely isolated. Let us solve another example. Draw the free body diagram of a ball of weight W supported by a string AB. Now a ball is here, it has a weight W and it is supported by a string AB and it is resting on a smooth horizontal surface at C. This is the smooth horizontal surface and it is resting at this point C. When a horizontal force is applied to the ball as shown in figure, a horizontal force F is applied to the ball as shown in figure. So first we have to completely isolate the ball. The ball will be completely isolated. Okay. And we will show when all the supports are removed from there, means when it has been isolated. So we will have to remove this support and also this string AB. So the first reaction that will act will be this weight W in the vertically downward direction. This weight W will be in the vertically downward direction from the center of the ball. Second reaction will be this force F, which is acting horizontally. The third reaction will be the normal reaction at this point C. When this horizontal support is removed, a normal reaction will be exerted on the ball in the vertically upward direction. Let us say that this is RC, as it is at the point C. Let us call this normal reaction as RC. And also, due to the string, there will be a tension which will move outward from the center. So this tension will be in the direction of the string. It will be in the direction of the string, and this tension is given by this capital T. So again 4 reactions are there. First is this weight W, second is this horizontal force F, third is this normal reaction RC at this point C, and fourth is this tension T, which is in the direction of the string. Clear? Let us solve another problem. Now this problem will be based on FBD as well as the conditions of equilibrium that we have seen in our previous video. A circular roller of weight 100 Newton and radius 10 centimeter hangs by a tie rod AB equal to 20 centimeter. So this is a circular roller. It has a weight of 100 Newton and radius is 10 centimeter. This is the radius, that is 10 centimeter. It hangs by a tie rod AB which is having a length of 20 centimeter and rests against a smooth vertical wall at C. At C it is resting. So we have to determine the force F in the tie rod. So this is the tie rod AB. So we have to determine the force F in the tie rod and the reaction at point C, the normal reaction at point C, that is RC. So 4 options are given to us. We have to find out the correct option. So before finding out, we need to know, we need to create FBD of this ball. So we know that we have to completely isolate the ball in order to draw the FBD. So FBD of the roller, it is called as the circular roller. So we will say that this is the FBD of the roller. So the FBD of the roller will be given as, we will first isolate the roller, then first weight, first reaction or first force will be the weight. The weight of the circular roller is given as 100 Newton. So this is the weight that is given as 100 Newton. It will act from the center in a vertically downward direction under the action of gravity. The next weight will be this tension in the string in the tie rod AB. This tension will move outward. So this is the tension in the string or in the tie rod, and it will also pass from the center. So this tension force is given as capital F in the tie rod, that we have to determine. This is given as capital F in the tie rod. Also we have to determine this normal reaction at this point C. So normal reaction will be somewhat like this, and it will also pass through the center at this point C. Okay, so let us say that this is the normal reaction RC. Now we have drawn the FBD of the roller, but we need to find out this angle theta. Let us say that this is the angle theta. We need to find out this angle theta. Here this triangle ABC, it is a right angle. Triangle ABC is right angle, right angled triangle. So as it is a right angle triangle at this point C, we can find this angle theta. So if we apply cos theta is adjacent upon hypotenuse. So cos theta will be 10 upon hypotenuse is 20. So we will get the value of theta as cos inverse of 10 by 20. So theta comes out to 60 degree. If we solve this in the calculator, theta will be equal to 60 degree. So this angle is theta, means this angle is theta, isn't it? This angle is theta, that is, this is 60 degree. Now in order to find out this force F and this reaction RC, we will have to resolve this force F. As this force F is inclined, we will have to resolve it in 2 directions. One direction will be horizontal and the other direction will be vertical. So this is the horizontal direction and this is the vertical direction. Now as this angle is 60 degree, so obviously this angle should also be 60 degree. Now as this component has the angle, so this component will be the cos and the other component will be the sine. So here this will be F cos 60. This force will be F cos 60 and cos 60 is 0.5. So we can write this as 0.5 F and this component will be F sin 60. So this will be, sine 60 is 0.866. So we can write this as 0.866 f. Now, what are the conditions of equilibrium? The conditions of equilibrium are, there are three conditions. First condition is that algebraic sum of all the horizontal forces should be equal to 0. That is, summation fx should be equal to 0. Now here summation fx means all the horizontal components. So here we have this RC as a horizontal component and point phi f as the horizontal component. Also, one thing we have to keep in mind that rightward force will be positive and leftward force will be negative. So here this will be, as RC is going right, this will be plus RC, and this 0.5 f is going to the left, this will be minus 0.5 f, as left force are minus and right force are plus. So this will be RC minus 0.5 f, there are no other horizontal force. This will be equal to 0. So we can write this as RC is equal to 0.5 f. We have transferred this 0.5 f to the right hand side. So RC is equal to 0.5 f. The second condition of equilibrium is that algebraic sum of vertical components of all the forces should be equal to 0. That is, summation Fy should be equal to 0. Now here vertical components forces only we will take into consideration. So this is a vertical component and this is moving upwards. So all the forces moving upwards will be positive and forces moving downwards will be negative. So this force is moving upward and this force of 100 Newton, it is moving vertically downward. So we'll write this as 0.866 f. This will be plus as this is moving vertically upwards, and this is minus 100 as this is moving downwards. Minus 100 is equal to 0. So from here we can find the value of f. This will become f is equal to 100 divided by 0.866. So on solving, we get the value of f as 115.47 Newton. The value of f comes out to 115.47 Newton. Now, this value of f, we can substitute it in this reaction, in this equation. So when we substitute it in this equation, we will get this as 0.5 into 115.47. So on solving this, we get the value of RC. RC value comes out to 57.73 Newton. Okay, so here F is 115.47 and RC is 57.73. So the correct option is option A.